Good morning, good afternoon, good day to everyone. Welcome to another episode of Launch Your Career. I'm really excited to cover machine learning engineer as well as machine learning scientist. We're going to talk a little bit about some of the potential differences in exploring an engineer and a scientist focused role and things like that. And for all of you that tuned into us last week, we covered data scientist. And so this is an opportunity for us to really kind of think about compare and contrast some of these different data professions. We're going to focus more on these throughout this stream and other episodes, including data engineer in the future as well. But before I get to that, I want to start to welcome our guest, Abhishek. Welcome.
Thank you. Thank you, Justin. Yeah.
Yeah, it's great to have you. One of the cooler conversations that I think we were talking about before as we were kind of prepping and just kind of getting to know each other on this is you are a fellow footballer, a soccer player, and you follow the sport and things like that. So
Yeah.
tell me a little more. I'm super passionate myself.
Yeah. So I grew up in India. So at that the state that I grew up in, like they had a lot of soccer fans, and we used to follow a lot of the European soccer leagues,
Yeah,
like the
yeah.
EPL, the Spanish league, the La Liga, and those. So that's where my interest grew into soccer, and when I started joined my engineering college and started studying about it. So one of the things that intrigued me into soccer and also into machine learning or into data science was like if I can use an historic data set, right? A football data set or the FIFA data sets, which are open sources, right? And can I predict who could be a winner or who could be the star player, right, in the next World Cup or in the next Euro Cup
Hmm.
that's been played, right? And like with anything that you're trying to learn, you can learn the best by like doing something hands-on, right? And
Yeah.
if you're able to do something hands-on which you're passionate about, like helps you learning better, right? So like at one of the early stages was like trying to use an historic FIFA data set and then trying to see if my predictions or whatever I'm using to predict them, right? Right, and those machine learning models, does it does it match with what the outcomes are, right, of that
Yeah.
tournament, right? So that way, yeah. And you get a lot of learnings in that process also, right? Like one of the learnings that I had was like you cannot go back too much in history to use that data set, right? To predict those, right? Because you have to look at more recent trends to analyze things around how the outcome will look like, and those are some of the things which intrigued me into machine learning. Yeah.
Yeah. Yeah, that's super cool. I've never played around with the FIFA data set like that before, but I imagine, it's a scenario in, past data does not always predict future
Correct.
results. That is the science, obviously, of data science and machine
Yes.
learning. But in this case, like players are human beings, right? And
Yes.
so, our bodies change, or we may,
Yes.
mesh better with a certain team
Yes.
or things like that. So it's an area where like the data is very fascinating, but it may not be the only
Oh,
context by which you evaluate a player or you use recent data or trend
yes.
line. Yeah,
Yep. Yep. That's the thing.
very cool.
And from that point, it has evolved a lot also, right? It's being even used in today's world, right? For a lot of analysis, even for injury analysis, right? So like when during a match when there are players that are clashing with each other, like you can even use machine learning and computer vision technology, which is part of the machine learning ecosystem or the data science ecosystem, to do a assessment around how critical that clash is, right?
Yeah,
Or when they collide, yeah, those things.
yeah. Very cool. I have a parallel in my life, which is my son plays soccer. He's on a premier soccer team, which is kind of serious at the 11-year-old level, about as
Yeah.
serious as you can get. He's super passionate about soccer, and they even at age 11, they have telemetry. They wear a little sensor in their shoe that checks step count and strides and
Yeah.
intensity level. You can use that data set to then do a heat map across the entire field, so you can see in this case where my son runs around, and you can even like evaluate it relative to the other.
Place.
Kind of weird again at the 11-year-old level,
Yeah.
but it's a cloud product, and so it features a camera that looks down over the field, and so then it can use computer vision to then track which player is going where, and it can see
Yeah.
like his name is Austin. Pull me all the moments where Austin made a defensive stand. He's center back, right? So
Oh,
defensive stand, he prevented a goal, or he got the ball out
oh,
of bounds, or how many times does he give up a corner kick versus a throw in, and that's so unfortunately,
yeah.
that server it doesn't have like an API for me to play with the data set, but I'm fascinated by the experience, even like in like the 11-year-old.
Oh, yep. Yeah, and that's how a normal data scientist or a machine learning engineer or a scientist goes through, right? So what you described is more around like the descriptive, around how Austin is playing, right?
Yeah,
And then the next stage of it is would be to use that, compare it with other players, how they are playing, and provide him suggestions around how he can improve, right?
yeah,
So
yeah.
that's the prescriptive part of it. Yeah.
Totally, totally. And as a parent, like I always try to remind myself that, I use this data, but again, he's 11 years old. So it's not like you need to do this, this, and this. Like it's much more being encouraging. Like he's fascinated. Like maybe he'll be a data scientist or machine learning engineer someday, discovering the data and
Yeah,
such. So
definitely.
very cool. All right. Well, before we get more into machine learning itself, just a reminder to all you out there, we Microsoft Reactors, we have a code of conduct. Be friendly, be respectful, be polite, share your perspective, be kind and considerate of others here. We want to create a great, welcoming community, and we've seen that so far with already some people in your preferred chat. Glad to meet you, Uganda. Charlie, welcome. Sanjay, I see as well. Sean. So it looks like we got a great group of people. Please ask lots of questions and today, and we'll be sure to get to that as well. All right, so let's keep going. I always like to begin these episodes recently by asking ChatGPT, Bing in this case, that is enabled ChatGPT as well. And I did this last week in Data Scientist, and ChatGPT nailed it pretty well. Talked a lot about data preparation and such. But in this case, a machine learning engineer is a type of computer programmer that is responsible for designing self-running software to automate predictive models using large data sets. I don't know, Abhishek, what do you think about that? Is that a pretty good definition? What do you think? Is it missing something that you might see on the screen here?
This kind of encapsulates a life of a machine learning engineer or a scientist. A lot of it, a machine learning engineer or a scientist, is kind of responsible for the scalability of the model or the availability of the model, right? Once the model has been built, tuned, and machine learning engineer kind of takes it, and irrespective of whatever resources or services they use, they kind of try to make it scalable, right? So that when, say, from it goes from 10 users to 5,000 users, right, it should still give the same SLAs, right? So yeah,
Yeah.
I think, yep, it definitely encapsulates it pretty well. Yeah.
Yeah, it's pretty good. Highly scalable code. We're going to talk more about that. I don't know about that keep impeccable documentation, though. I don't know, Abhishek, do you keep impeccable documentation as an engineer?
Yeah, so as an engineer, yes, as an engineer, we are responsible for keeping the documentation so that it serves two purposes. We try to keep it as granular as possible, but mostly highlighting the points where there are interactions, or I would say where there are integration points, right?
Yeah,
Because
yeah,
those are the points which might have issues, and so highlighting them in the document so that, say, in the future, if somebody else is looking at it and they're facing issues, they know kind of the points they want to look at, right? So
yeah,
that's where the documentation helps, and we do try to keep it as granular as possible, but also encapsulate the business value to that
yeah.
document, right? So somebody reading it, yeah.
Totally. Perhaps you could ask ChatGPT to write your
Right,
impeccable
yeah.
documentation. ChatGPT, make my documentation impeccable. All right. Like and then you can edit the delta. Good stuff. Well, pretty good definition there. It's amazing how you can see the sources that ChatGPT is pulling in that particular definition as well. So, all right, before we get to the next thing, I think you all who have watched this show before, we have a cloud skills challenge. We're exploring 24 different job roles throughout this year. across people in Microsoft, anywhere from data analyst to security professional to web developer to today's machine learning engineer. If you want to check that out, we've added one learning module on Microsoft Learn for each of the job roles. Obviously, there's so much more. You can get certification in this space and in machine learning in general. But if you want to start somewhere, you see the web URL there is a good way. Launch your career skills. All right, so Abhishek, tell me, so what inspired you to pick this career? Was there like a magic moment or something that kind of got you where you are?
Yeah, so as I stated earlier, one of the things was the football data set. It's just out of passion, right? Me trying to predict, me trying to see if that player or that team would be the top three, right, in the next league or something like that, right?
Yeah.
Yeah, so that's when, and then when I started my career, I started in the software development team, and also which was very much focused on the customer experience part of it, right?
Hmm.
So during that time, I saw a lot of analysis or a lot of business decisions being taken based on analysis around how the customer experience has been, right? And like trying to find deep insights around it. So that's one of the reasons that intrigued me, and like then I started to go deeper into it, right? Going from a software developer to kind of a data engineer and a machine learning engineer role, and then exploring the data science part of it, right? So that's how my trajectory has been. It's mostly about you have to passionate about data. That's the first thing. You have to kind of accept the fact that you might be trying to find an insight and you might not get it, but you might find an alternate insight. So you have to have an open mind to it,
Hmm.
right, around what you're trying to achieve, right? And during my career, I've seen like with any data sets or with any form of data, there is always an insight to find out, right? So now it could be through a machine learning algorithm, or it could be through a manual analysis effort, but both of them have their own importance. So that's kind of the intrigue points. And then I got the right opportunity in the right team, which was focusing on the data science around the customer experience space and trying to derive business insights from it so that they can enhance the revenue, right? The product
Yeah.
revenues. So yeah, that's how my journey has been in the machine. And now I'm as a senior machine learning scientist, kind of working in the customer experience space for Microsoft. Yeah.
Yeah, very cool. Customer experience. Well, we'll talk about that because I think if I recall, you work on Microsoft Learn in terms of customer insights amongst other things. So
Yes,
we'll
yep.
talk about that. We have that kindred spirit as I've spent a lot of my recent career thinking about Microsoft Learn as well. But let's dive in a little bit more on. You mentioned scientist and engineer, right? And I
Yeah.
think you had a title shift in Microsoft recently as machine learning scientist. But can you kind of help us compare and contrast the distinctions between like a data scientist
Yeah.
and a machine learning engineer? And I'll throw a machine learning scientist in there as
Yeah.
well. You know?
Yeah. Yeah, I think of it like a data scientist is kind of responsible for building the model, right? Or trying to tune the model and trying to find the best parameters for that model so that you
Yeah.
can get the best predictions, right? And while the data scientist is doing that, they work very closely with a machine learning engineer or a scientist, right? Now, the clear boundary is the machine learning engineer or the scientist is kind of responsible to scale that model, right? Or
Yeah.
make it highly available, or kind of take that development of that model and modularize it and then making it scalable, right? Say for example, say a data scientist might be doing in the initial stages when they're doing the analysis, trying to find insights, trying to tune models, they might be using a single notebook to do all of that, right? Now as a machine learning engineer or a scientist, you are working with the data scientist very closely, so you know the business integrities or the nuances of that notebook, right? But then you take that and try to modularize that code in terms of the integration points, in terms of the data preparation, the feature engineering part, right? Which goes as input to the model, right? And you kind of modularize them into different Python modules or or different notebooks, but and then use services which are appropriate for those stages, right?
Yeah.
Because all of those modules might need a different type of resources, right? Like for example, the data prep might need a high memory resource, whereas the model training might need a high GPU resource, right? So
Yeah.
you want to separate them out. So that's the architecture, the design, which the machine learning engineer, the scientist, is responsible for. But to do that, the engineer, the scientist, has to work very closely initially with the data scientist so that he knows where to do those splits. He
Yeah.
also
Yeah.
knows that. Yeah.
Yeah, it makes sense that there's some overlap, right?
Yeah.
Similar
Yeah. Yeah.
to data analyst and data scientist,
Yeah.
or machine learning
Yeah.
engineer and data engineer, right?
Yeah.
People who are really working with data and large data sets. But like one of the things that I hear from you is it's all about the scale
Yeah.
component.
Yeah.
I think of the scale of like a chat GPT or an AI model, a computer vision model we were mentioning in our soccer and football
Yeah.
data sets earlier. And so, the part that I think is really interesting, especially for all you out there that are evaluating different job roles, is you have, the data scientist is kind of thinking about I'll begin with the notebook, right? The Jupyter notebook, right? You're building a model, you're using Python libraries, possibly might be using PyTorch or TensorFlow or deep learning things, but you're building the model and visualizing the model. But what I think is fascinating about your work, Abhishek, is then once you have something that's good, is like you got to figure out how this can have millions of users
Easy.
call the model, or it can function at large scales, which
Yeah.
is which is what like a chat GPT or is what is like a large scale AI model is. And so somebody's got to
Well,
think about those
yeah.
pieces, right?
Yeah.
And so yeah, tell me a little bit more of like the how, like you mentioned architecture in that. Like, so how do you, like, let's say I'm a data scientist and
Yeah.
I give you my notebook, and my notebook is, highly sophisticated because like I've taught, introduction to data science, but like, I've got a classification model
Yeah.
that's in a notebook, right?
Yeah.
So how would you start to break that apart and modularize?
Yeah.
What different
Yeah.
parameters or things would you consider
Yeah.
in that?
Yeah, so at a high level, I'll kind of try to first break it apart into a data prep and a data enrichment or a feature engineering section, right? So the
Uh-huh.
data prep is more about like when you're connecting to different sources, because it will never, the data will never be from one source, right? It would be an integration from different sources where you're pulling the
Yeah.
data for training a machine learning model, right? So you separate that part out, and then you kind of convert it into a modularized Python library, right? Which you can use an Azure Data Factory to deploy, or a Azure or a Microsoft Synapse environment to deploy, right? A Spark environment to deploy that, right? And then you kind of run it there, and then you do the feature engineering part of it, which is basically converting those parameters to vectors, right? Which goes as inputs to the models, right? And then you separate out the model training part, which you can use the Azure machine learning service, right? Which kind of takes care of a lot of the scalability and the availability part, abstracts it for you, right? So you kind of
Yeah.
use the Azure machine learning service to do it. So that's how I would kind of spread it out. So that's the training part, right? And
Yeah.
then
Yeah.
then there would be a section which is the inference part, right? When somebody has trained the classification model, somebody wants to call it to use it, right? So now at that case, that would be a different pipeline or a stage where you host the trained model, right? And you can use like widely we use the Azure machine learning service to host them, right? And it kind of provides you an API endpoint or a batch endpoint where you can process them, right? So that's how I would modularize and split the
Yeah.
flow at a high level. Yeah.
Yeah, it makes a lot of sense. Like some of the tools that you described there are not just like the traditional data scientist tools of a
Yeah.
Python library and notebook, for example.
Yeah.
Like you're getting into, you mentioned hosting multiple data sources, for
So,
example. And
yeah.
what if those data sources are changing or get
Yeah.
updated regularly or are based on inbound data, like I don't know, like a IoT or an edge device or something like that. And so, to
and
some
and
degree, sorry, yeah,
and
go ahead.
that's yeah, and that's a very good point, Justin. And that in our world we kind of call it a data drift or a drift detection, right? So the reason for using the Azure machine learning services, right, and that's a good point of a good service to host the models, because it kind of gives you an out of box capability to detect them if there are changes in the data sources, right? Because your trained model might degrade, right? if the patterns which were previously trained on changes also. Yeah.
Yeah, makes sense. And you also talk about like working within parameters or constraints, right? Like you mentioned GPUs and hardware, and so like is part of the role more about like picking the right hardware for the right model, or maybe describe to me a little bit more about that. I heard that GPUs are good for data science. Tell me
Yes.
more.
Yes. Yeah. Yeah. So part of the role is also to use. I won't say use the choose the right hardware for the job, but use the appropriate service that is needed.
Service.
Kind
Okay.
of part of it, right? So, like I talked about the data prep and the feature engineering, so that's kind of heavy on the data transformation side, right? So, Spark provides a pretty good landscape for that, right? To do things at a scale, right? So, you kind of try to use a Spark environment, which is like I mentioned about the Azure Synapse environment, right? For
Yeah.
that,
Yeah.
right? And now, when it comes to the model training, if it's a deep learning model, one of the requirements is like to use GPUs to make it faster, right? Or do parallel training, right? So at that point, we kind of try to use the appropriate GPUs if needed. But whereas if you're using a more classical model training, like a classification or a linear regression model, right, around that, you don't need GPU. So you don't want to do an over commissioning of things, because at the end of the day, you're trying to make the best use of the resources that are available, right? And use the appropriate one which is
Yeah.
needed for that scale. Yeah.
Yeah, that's a really good point, and it was something that I heard from Microsoft Build this recently. We were talking about Azure Open AI Service and training models or building features off of ChatGPT, Open AI and things like that. And one of the things that I think was mentioned at the conference was that find the right hardware and the right
Fine.
infrastructure for the right model. Sometimes using ChatGPT 3 is sufficient, right? Where GPT-4, for example, might be a lot more expensive, or if you're spinning up GPUs all the time for just a simple linear regression model, then you're probably leaving some money on the table, or using resources
Yeah.
that are be driving a Ferrari when all you just need a basic car to get you from point A to B, to get to that and things like that. And so like knowing the right infrastructure, knowing the right services at the right time,
Great. Yeah.
that really
Yeah.
feels like
And that kind of also translates into the data scientist or the machine learning scientist role also, in a way, uh, like trying to figure out which is the appropriate model versus the business value, right? Say for example, linear regression, which is which is more classical and simpler model, right? If you use a linear regression for a particular use case, and what is the extra lift that you are getting if you use a deep learning or a more sophisticated model, right? And how much of that lift is applicable to the business value, right? So
yeah,
there's a choice that a data scientist or a machine learning scientist also has to make at some point, right?
yeah,
Like to balance out the business value versus, because a deep learning model will need a lot more resources to train on, right? The cost of those resources versus the business value that you are, or the lift that you are bringing. Yeah.
yeah. You make a really good point that I'll contrast from our episode on data scientists last week. Is I'll say one of the theses in that episode, it was the importance of communication and
Yes.
communicating insight to your stakeholder, to talk to business, to understand the kind of the data problem and context and things like that. Obviously very important, very a lot of overlap obviously with the roles, but what you described to me is the how, right? You're
Yes.
thinking very deeply
Yes.
about how do I enable this? How do I create the best value?
Yes.
How do I get it to scale at the level that it's a great product for day-to-day user to
Yes.
use the
Yes.
model and things like that. Yeah. Very cool. Very cool. I think it's a fascinating role. Abhishek, did you come from a background in software engineering prior, or did you start as a data scientist? Like, how did you kind of find the engineering niche in the data professions and such?
So I start like my first job was related to a software developer, software engineer path.
Yeah,
But
yeah,
it was with a customer experience team, so there was a lot of data insights and like hidden data insights or hidden business values that were part of the job that we were trying to derive. So and like then use them to implement and produce better products for the customer, right? So it
yeah.
kind of overlapped and intrigued me in seeing like how much of a value just from a raw data like the analyst or the stakeholders can derive so that they can take decisions, right? decisions, right? Data driven decisions. So that was one of the reasons, like that was one of the intrigue points to move towards a machine learning engineer or a scientist role. Yeah,
Awesome.
that's it.
Let's take an audience question that's related to this. So Vianney asks, how did you get your first role as a machine learning engineer?
Yeah, yeah. So my first role was related to like and that's a good point. Like when I started, like it was a software development engineer, and at that time, machine learning engineers or data scientists was not a very common role to have, right? And then when I saw the insights or those business values that they're deriving, right? And then it was a basic linear algebra algorithm to derive those same insights, right? And that intrigued the stakeholder to explore that path to derive those business insights so that they can design better roadmaps for their product, right? And that's where a role transformation happened, and it was moved to a data science team where they were mostly around the data analysis, but like I was a machine learning engineer who is helping them to build those insights at a scale so that they
Yeah,
can take it on a regular basis. So that's how I got my first role as a machine learning engineer. It's all about like the passion and the curiosity to know how a decision is being made, right?
yeah.
So it started from there. Yeah.
Yeah, and you touch on a point that happened for me in my career too. Is I didn't even know what machine learning was until maybe about 7 years ago or so. You know, I started in a career in data and analytics for Microsoft. I mentioned this last week that I started as a marketing analytics manager here at Microsoft, and thought about kind of the technical stack of that before Power BI was around. There was lots of SQL still, ETLs and data models and presentation layers and things like that, but the industry has evolved, and this has
Mm.
become a common area, which leads me to a great question that Sanjay asked just at the very beginning of the stream. I wanted to get to, but like, I'm an Azure data engineer. How can I add machine learning to my skill set? How do I make that bridge more, as an
Oh,
engineer
yeah.
too?
And this is a very good question, right? So as a machine learning engineer, or there's a lot of overlap, and it's a very sweet spot between a data engineer and a data scientist, but leaning more towards the data science part of it, right? So as a data engineer, there's a lot of the skills that can translate into a machine learning engineer. The main difference is like you kind of go to the next stage where you're trying to uh, use a machine learning algorithm to derive those features, right, or the hidden features, right? And to derive those, a lot of it needs a data engineer role also. So I would suggest like at least you can start with some of the basic machine learning algorithms like classification and linear regression paths algorithms, and those can, and knowing those basics would help you make the transition also easier,
Yeah,
because that's kind of the difference, but the skill set or the technical skill sets are still similar, yeah,
yeah.
between the two. Yeah.
Awesome. Well, just a reminder, or for those of you that are just joining, if you want to explore all these things, we've got a Cloud Skills Challenge for you on this, where we do talk about like the differences between data engineering and machine learning, data scientists and such. So if you want to explore that on your own time, feel free to do so as well. So Abhishek, kind of next question or next kind of bridge here. We'll come back to a little bit to the tool and the tooling set because I think that's interesting later in the stream. But tell me more a little bit more about like the day to day. Like, where do you spend most of your time? Other than meetings, but who do you work with? Just tell us a little bit more about like what a typical Wednesday is at Microsoft as a machine learning scientist.
Yeah. So a regular day will normally start with like those pipelines that I was talking about, right? The feature engineering pipelines, the data preps, right? So if there are any alerts, or looking at those alerts, right, to see if it is important or do I need to address something. So that's where a regular day kind of starts by looking at those alerts. Then it moves to the tasks that you have with your stakeholders, right? A lot of the time in the day is spent around discussing with the data scientist along with the stakeholders, right? Basically trying to understand the business value and trying to trying to put yourself in the stakeholder's shoes to see what type of insights or they're trying to derive, basically frame the business problem into a technical problem, right?
Mhm.
And that's a very initial journey, and that's a very important journey so that everybody is on the same page, right?
Yeah.
And then it moves towards more of a technical side where the existing tasks or existing pipelines that I'm working on, I'm building on the scalability part, making it more democratized so that it could be a self-serve, easier to onboard onto, right? So those aspects of it. So that's how a regular day kind of goes on, like talking with stakeholders, understanding the business value, verifying whatever the insights are being generated, are they adding value, or is the stakeholder looking for something else, right? So those, the communication part and the working backwards, I kind of call it that way.
Yeah.
The working backwards part of it, yeah.
Yeah, makes sense. What's more challenging? Like, I think if you could change something or something that just kind of, if you would had something to say for those who are exploring this as a profession, what's the thing that makes you pull hair out of your head or whatnot?
So it's there are two aspects. The like, you have to be very passionate about analysis on data, and that's the good part. And it's also the challenging part, because you will never kind of get the data in the format that you want, or
Uh
you
huh.
never get a clean source of the data, right? And you will always get it from a variety of places, right? And it could be variety of systems, it could be variety data types. Um, that you are getting in, but trying to combine all of them to create a single source of the truth. That's the challenging part. And I would love to kind of, if to be in a world where I don't have to do the data cleaning part or do that part of it. But I would say, like, that's also a crucial part. But whether I like it or not, but that's a part of the day-to-day life.
Yeah, that's a good one. I think from my own limited encounters of working with data sets and things like that, like accepting the fact that your data will not be perfect. Yes,
Perfect.
you have techniques and ways to clean data and prepare it and to munch things together, but for those of us who might identify a little bit more perfectionistic or whatnot, there's an acceptance process, I think, and recognizing that whatever data set you're going
Yeah.
to get, it's definitely not going to be perfect.
Perfect. Yeah, and it brings its own ambiguities with it. But the interesting part is your ability to kind of navigate those ambiguities and get to the insight or the end goal, right? So that's also the more interesting part, yeah, of the
Yeah.
work.
Yeah, awesome. Well, I've got a great question that's kind of related to this as well. And so Tobogo on LinkedIn is asking, my interest in ML and AI started recently. For a complete beginner, what would be the best learning path? Complete beginner.
Okay, I would say start with the basics, and like, and Justin had a link also about the learn your skills, so that I would definitely ask you to look at that. But the start with understanding the basics, like, which is about the classical models, which were based on like linear regression, classification, the classic ones, right? And there's a lot of resources along with the link that he's showing, where you can get details around those and learn about those, because once you have those basic understandings around how a model training works, right, that would help you to adopt the more advanced models, like the deep learning ones, the AI, the neural nets, and those things. But the
Yeah,
base is very important, right? So like any courses which involves the basic learnings about the classification, um, linear regressions, and those things, like the decision tree based algorithms, yeah, those would be
yeah.
helpful to start with.
Yeah, I completely agree. I've mentioned it. I've taught introduction to data science before, and I think even in this world of Chat GPT, where things where it's more readily available to find answers, you have to know the terminology, and you have to know the basic functions. And so, Tobogo, what I'd recommend is understand the difference between classification and clustering, and practice those with data sets. Find a data set that's fun. Abhishek and I we were talking about soccer earlier, and so like pick a data set that you want to explore. I think would be a great way to begin. Fortunately, most of these beginner materials are free. Certainly, they are on Microsoft Learn, or we Microsoft offer free skilling things. This live stream is free, or something that we love to do because we believe that skilling is important for the community and things like that as well. Yeah, no. Any other resources, Abhishek? Have a learning platform or a particular module or things that you've used recently?
Yes, one of the things that I kind of follow also, like to be up to date with the market, is Andrew Ng's courses on Coursera also, right? So those are some of the modules that can help you learn them a lot, which is free and open, right? The Andrew Ng courses for your upskills, and along with, if you're starting new, along with learning the algorithms, also have some basic understanding of data transformations or data engineering, because they kind of very much go hand to hand together. You kind of have to do the data transformation or the cleanup so that your models can perform better, right? So it's better, you don't have to know in depth about that, or the scalability part, but you need to have a high level idea about it. Yeah. So that's
Yeah,
something
very
like
cool. Sanjay was making a comment here. I'll throw up around statistics. I don't know if you've read the book or whatnot, Abhishek. There, but I will say, as you're thinking about that, like statistics is super important. I think it was the basis of what I took in college and kind of came to an understanding when I started a career in data analysis and analytics and things like that as well. But knowing these things and knowing how to use math in it, yes, there are great libraries that you can use, but you need to know what function to
that.
call or what to ask ChatGPT. It's knowing how to ask the question, I think.
Questions.
So
Yep.
I don't
Yep.
know. Have you read this book or have you read other
No,
statistics
no.
or things like that?
I've not read this book, but this is a very good point. Like statistics is the base for all the machine learning algorithms, right? I'll give a quick example. Like I kind of mentioned about working in the customer experience space, right? So one of the processes before a product is released or a feature is released, what they do is called A/B testing, where they have a small audience where they release a section of that feature, the new feature, and then you gather the data and you try to analyze and see whether it will bring an lift, or it will add to the revenue growth, right, when you release it to the mass, right, that feature to the mass, right? So the analysis involves very, it depends very heavily on statistics, that analysis, because you're kind of trying to statistically prove that like a small audience is equivalent to your larger audience, right? The statistical relationship that you're trying to build, right? And that's how you get to a point like, okay, this feature could help uh, move the needle in case of the revenue when you release it to the masses. So
Yeah,
yeah, knowing the statistics is very important, right? And there are multiple algorithms that are used, like we call it Bayesian algorithms, you call it frequentist, but as Justin mentioned, like you need to know the base of it or have a high level overview, and then ChatGPT is a very good partner to solve that cold start problem. Once you know like the terms that you want to Google on, or that you want to search on in ChatGPT. Yeah.
yeah, I agree. I've tried GitHub Copilot recently for code completion and code
Okay.
translation, especially for data science related. It's pretty amazing.
Yeah.
You can also just enter code into ChatGPT and
Yeah.
get ask it to convert. I saw a question earlier about C++, for example. So at least theoretically, you could take Python code and data science and convert it to C++. But
Yeah.
I haven't heard many people convert to C++. It tends to be a different language, lots of gaming and things like that for C++ and C sharp and such. But theoretically, you
Yes.
could do that, right?
You
But
can do that.
yeah. Abhishek, like, how are you using ChatGPT? Are you ChatGPT? Are you starting to experiment with that in kind of your day to day workflow, coding and
I,
such?
I kind of use the chat GPT. I've been using it for say the last 3 4 weeks around, and kind of I look at it as my partner when I'm coding, right? So
Yeah,
I'll,
yeah,
I'll give you a very simple example, right? So say, if think of an use case where I'm trying to predict the price of a house in an area, right? So from my understanding or from my learning, I have some idea about using linear regression, right? But like I don't have a sample code to start with, right? That's where ChatGPT can help and will solve that cold start problem and give me a production ready code to use it. Similar to the point that you made about converting from Python to C++. Yeah, but I've not heard a lot of people doing that part, but I've seen the other way around, like taking a C++ or a code in R and trying to understand it and trying to convert it into Python, because what they're trying to do, that library or that use case can be done more seamlessly in Python, right? So for example, like that's an example I can give off. Yeah.
yeah,
And you can always and you can think of it as, you mentioned about the co-pilot, and think of it as a partner that you have, like which will give you the contextually a production grade code, or a or help you solve the cold start problem to complete your code, right? If you're trying to build something, yeah,
Yeah, I like that. Very
definitely.
cool. Well, Ravanth asked a great question, and I think most learners are interested. If you are an interviewer, smiley face, what would you expect from an entry-level machine learning engineer?
Yeah. For an entry level machine learning engineer, is, as I mentioned, some knowledge about a high level knowledge about the data engineering part of it, and a little advanced knowledge about either one of the basic classical algorithms, be it a classification, clustering, or a linear regression. Because, in my opinion, like if you have knowledge about one of those, you can translate or pick up any new advanced algorithm pretty easily. You can understand the maths, and so yeah, some basic knowledge about from the data engineering part, the machine learning engineering, which is the feature engineering part of it, and knowledge about one of those data science areas like a classification or a clustering or a linear regression part. Yep.
Yeah, yeah, I like that. I like that, and it's kind of in the spirit of what Vianney said here. You know, he is a master's in computer science and getting into machine learning. I'll offer this as like you know, as a hiring manager myself, I work in DevRel and in other elements where it's the intersection of communication and engineering. Practice, you know,
Yeah.
have some projects, have a portfolio, have some data sets you've explored. You know, if you're a master's student in computer science, you probably have some pretty good foundational skills. And so, you know, yes, you know, watch things like this. Yes, go to Microsoft Learn and try out different modules. But if you have that degree of sophistication, you know, just practice. You know, is there, I don't know, Abhishek, is there a project or something that you did, like a particular moment in your career where you like did this project and you used that project, you know, as an example for hiring manager or for best practices that you learned and that type of thing?
Yeah, so it does a project like I talked about the football data set and also about the customer experience and the recommendation engine. That was one of the projects that I worked on was related to recommendation engines. So that's also like something new and very advanced for me to do it. But as a student, I would say if you are a student of masters, you already have the foundational knowledge. It's all about practice, be it with data science or machine learning engineer or any ML space or data science space. Practice would The only way you will learn is if you do it yourself. You will learn the best by doing it yourself. Like in my case, it was the football data set, and it was just out of curiosity, right? So you will always learn it by doing it yourself. And like there's a lot of resources. Like Kaggle is one where you can find use cases if you're looking for it. You can even participate in those competitions. So that also will give you a learning opportunity, like a hands-on experience, yeah, of a
Yeah.
practical use case.
Yeah, I agree. Like, I think, you know, taking advantage of community resources, like this Microsoft Reactor community that we have here. We have a student ambassador program where part of our commitment in the program is giving students the opportunity to speak and present in moments like this, right? As part of a Microsoft event. And so, you know, grab a data set, learn something, get to a point where you feel speaker ready and want to communicate that with some of your peers. You know, that teaching element and that sharing element is a great way to kind of lock in that knowledge, I think, too, you know. So, well, Kevin asked kind of a variation on a question we covered earlier, but I know like in streams, people come in and out. So this is slightly different, worded slightly differently, but what's the hardest part of your job? And let's take a little twist on this. Like within Microsoft, Microsoft is large scale, it's enterprise. You know, as a machine learning scientist, like you're thinking about scale. Is there something about scale that you find particularly hard, or the architecture part?
So, so in terms of scaling, right? So it's about having the deep understanding about the different services or resources that you are using, right?
Yeah,
In terms of using Synapse versus Azure ML versus a GPU instance and those things. So you need to have a very deep knowledge or understanding about how those services work or where they fit it. I would say in terms of scaling, one of the tough part would be to get a deeper understanding of those so that you can provide the right recommendation of the architecture, right, for your use case. So that's one of it. Other than the one that I mentioned before, like the variety of the data that we see at Microsoft, just because it's because of the scale of it. Yep.
yeah, completely agree. Well, for all you out there, just a reminder, you can learn about all this stuff on our Cloud Skills Challenge. There's lots of links and things like that as well. But we're wrapping up here pretty soon. Be sure to kind of type your last minute question. It's been a pretty good chat window, lots of discussions. I think I got to most people and tried to cover some of the questions here that cover them indirectly or through other things like that. But chat us up on LinkedIn and other places as well. But Abhishek, any parting advice for people that are starting their career or trying to enter the data sciences and as a machine learning engineer or machine learning scientist and such?
Yeah, just be passionate about what you're doing. Be intrigued, be curious. That's the
Yeah.
most important thing. Be curious because you will never know what the insight that you can derive. Be curious about it. And there's a lot of material, including the learn skills, the launch your career skills page, where you can get the basic knowledge of it. But once you get the basic knowledge, it's your curiosity which will take you to the next step, because I have to be curious and passionate about things, then you will learn new things, yeah, around it. Yeah.
Yeah, I couldn't agree more. Start with that football, that soccer data set,
Mhm.
or an open data set that
Yep.
focuses on social good, or
But yep.
anything that you find interesting. The more I think you know your data or know the data set, you have domain knowledge of the data,
Mhm.
allows you to practice the skills so that
Yep.
someday maybe you're dealing with a data set where you don't have that domain, or you have to utilize these techniques to kind of unlock an understanding of that data
Yeah.
too. So practice, practice, practice.
Yep.
For students, we've got an Azure free trial for you to use there. I know VS Code has a Jupyter extension, and so you can run notebooks locally without using cloud compute. You can also use a web-based version in code spaces. So Microsoft's got lots of products out there to help you practice and such there. So definitely take advantage of that. But
Yep.
practice makes perfect, as they say.
Completely agree. Yeah. Practice.
Very good, very good. Well, thank you so much for being our guest today, Abhishek. There was a great conversation. I really liked how we did kind of contrast a little bit of last week's data science episode. This was a very different and a good
Mhm.
conversation to kind of understand the relative distinctions and things like that. Which leads me to another point for all of you out there. Like, listen to many different people's perspectives in the industry and job role. Like, each person's experience and what we do is a little different, and so seek out other shows like this or other Microsoft Reactor events. For running things like this all the time, and we do care. That's why we love doing this. So Abhishek, thanks again for being a guest today, donating your time a little bit. I know you've got some busy data sets to work with, some customer insights on Microsoft Learn and such. And yeah, and we are going to air another episode of this later today for people whose time zone is preferred. But we also are going to be answering more live chat Q&A. So we'll air the pre-recorded video, and Abhishek and I will be able to respond to even more comments in chat. So if that's something you're interested in, feel free. Otherwise, this episode will be available on demand on YouTube, LinkedIn, Twitch, and other places as well. So. All right. Well, thanks. Have a great day. And from Microsoft here, have a great day for all of you learners out there. And we will see you next time. Thank you.
Thank you. Thank you for everyone for joining it. Bye.
Cheers.
Cheers.